Okay, here's the first problem from the take-home quiz, number 12 from section 7.3. You're asked to find the Laplace of e to the t times cosine squared 3t. You can't do the Laplace of this directly because we have a Laplace of a product. So what we're going to do is we're going to use the half angle formula to write cosine squared 3t in a different way. Specifically, this is going to be the Laplace of e to the t times 1 plus cosine 6t over 2, and then we're going to distribute the e to the t through, and this will be the Laplace of 1 half e to the t plus 1 half e to the t cosine 6t. Okay, well, this is equal to, the first one we know, this is 1 half times 1 over s minus 1 plus 1 half. Okay, now this is a translation here with a equaling 1. So this is 1 half of s over s squared plus 36 as s translates to s minus 1, which gives us our final answer of 1 half times 1 over s minus 1 plus 1 half times s minus 1 over s minus 1 squared plus 36. And that would be an acceptable answer. Okay, the next problem, this is number 32 from section 7.3. Inverse Laplace of the quantity 1 plus e to the negative 2s squared over s plus 2. So we need to split this up as multiple fractions. So the numerator needs to be multiplied out. When we do this, we get 1 plus 2e to the negative 2s plus e to the negative 4s all over s plus 2. This is equal to the Laplace inverse. Now we split it up as fractions, 1 over s plus 2, plus I'm going to put the 2e to the 2 negative 2s out front, times, so you see the inverse transform there. And then same with this one, e to the negative 4s times 1 over s plus 2. Excuse me. So this equals 1 over s plus 2, of course, is just e to the negative 2t. Plus we have a 2 here. Here, because we have the e to the negative 2s, this is going to be a unit step function with a equaling 2. So what we have here is 2 times, so then this function here automatically, which is e to, of course, to the negative 2t, will automatically be translated by that 2 per the second translation theorem. So this is going to be 2 times e to, again, we have the 2 here, so this would be negative 2, and then the translation, which is t minus 2, and then times the unit step function of t minus 2, and then plus the same thing on this one, but on this one, of course, a is equal to 4. So on this one is going to be e to the negative 2, again, negative 2 because of that, negative 2, and then t minus 4 times the unit step function of t minus 4. So that is that one. Okay, finally number 34 from section 7.4. They want you to figure out this inverse Laplace using a convolution. So this, of course, means that we're looking for a product here. So we can do inverse Laplace and just make it into a convolution and then make it into that integral. So it looks like, if we just do this separately, it looks like we're going to have 1 over s times 1 over s squared plus 1. So, of course, 1 over s leads to 1, basically, is that inverse Laplace. And 1 over s squared plus 1 leads to sine t. So what this is 1 convolute sine t, which is equal to the integral of from 0 to t of 1 times sine of t minus tau, d tau. Okay, so we have this here. Just to be careful, I'm going to do the u substitution. T minus tau du equals negative d tau. So this is going to be the negative integral of sine u du, which is the negative of the negative cosine u, which of course is equal to cosine u. And so this is going to be cosine of t minus tau from 0 to t, which gives us cosine of 0 minus cosine of t, which is 1 minus cosine t, and that's the solution. Off to this side, notice that if you can flip these, and you'll get the same answer. If you went 0 to t of sine tau times 1 d tau, by flipping these two, you will get the same answer. You can check that yourself. 1 minus cosine t. Okay, thank you.